what here? Platinum. What is the use of these one? These are the catalyst which can useful for what? A surface for the hydrogen gas, because hydrogen gas need a surface. The surface is provided by nickel, platinum and palladium. Now on this surface, the reactions will take place in which NO2 will convert into what here? NH2 group here. NO2 will convert into NH2. Right? See, hydrogen in presence of palladium. Isn't it? Ethanol is a solvent, but it is a solvent. Then how do you prepare aniline here? So aniline, this one is what aniline actually. This part is actually what aniline. For this one also same thing. What we are doing, NO2, nitrobenzene you have to take. The nitrobenzene, isn't it? Nitrobenzene we can convert how into what aniline by using hydrogen in presence of palladium or tin in presence of acid. Tin in presence of acid or iron in presence of acid. Then you take acid only. Don't take base here. If you take base, what happens? We get something different compound, azobenzene. So that is the reason I'm here underlining this concept is what acidic medium I'm saying. Acidic medium, iron scrap in presence of what? Hydrochloric acid, isn't it? And hydrochloric acid is useful because of the FeCl2 when forms, no, that will be hydrolyzed here. Because actually what happened, further reduction should not take place here. So definitely what happened, acid we have to take. Acid we have to take. Okay, right. So what are the reagents we are taking here? Hydrogen in presence of palladium or nickel or what happened? Platinum. This is R actually. R. First reagent. You can take one more reagent called what happened? Tin in presence of acid. Acid place I have taken HCl here. Third reagent, iron in presence of what? Same HCl. These are the three reagents we are using to convert what actually? Isn't it? Nitrobenzene into this one. The nitrobenzene into what actually? Aniline. See, please all of you note down in your notebook like this. Conversion of nitrobenzene into aniline. Conversion of nitrobenzene into aniline. What are the reagents we are taking? These are the three, because it is useful in the conversions. Most of the reactions, if you observe in the conversions, this type of reagents will be there. Okay, so nitrobenzene, how you are converting into aniline? By using these type of reagents, right? Next, we'll take second one, which is ammonolysis of alkyl halides. What is ammonolysis of alkyl halide here? So addition of ammonia to alkyl halides. Isn't it? In this very simple reaction, we can say RX, right? Reacting with ammonia. I am writing ammonia like this. Right? This is what ammonia. I am writing ammonia like this. Here you can place X is equal to what we can write here. X equal to, you can take chlorine, or you can take bromine, or you can take even iodine also in the place of halogen. R means you can take any alkyl group here, CS3, ethyl group, methyl group, propyl group, isopropyl group, like that you can take any alkyl group. Okay. Don't take what happened? Halobenzene. Don't take chlorobenzene. Don't take what bromobenzene, because in this double bond character gets. So take only alkyl groups only. Okay. So and what happens here? HX is removed. Minus HX is removed. Minus H. If it is X, what happens? Cl, HCl will be removed. Now what we are going to get? RNH2 we are going to get. RNH2. What? This is called primary amine. This is called primary amine. Again RNH2 I am writing over here. Is it visible for you? Whatever I am writing?
Yes, sir.
Yes, sir. Can I write like this? But RNH2 shall I write like this? This is also primary amine. RNH2 only. It is RNH2 only. But I am writing for our understanding purpose. I am writing RNH2 like that. Again reacting with what? Second alkyl halide. Second mole of alkyl halide. This is the second mole of alkyl halide. This is the first mole of alkyl halide. This one is the second mole of alkyl halide. Again HX is removed here. So what we are going to get here? RNH. This is called what? secondary amine. Okay. Again, the secondary amine shall I write like this? For our understanding, the secondary amine I am writing like this. For our understanding, secondary amine I am writing like this. Like this. Both are what? Same one. Again, reacting with third mole of what? Alkyl halide. Third mole of alkyl. Now what we get here? R, N, R, again R. With one lone pair. Because all nitrogens will have a lone pair. Every nitrogen will have a lone pair like this. Right? Now this is called tertiary amine. Again, if you do one more, lastly, if you do finally Rx, you are adding here. Here there is no hydrogen. Even though there is no hydrogen, what happens here? This lone pair no will give to alkyl group. X minus will be removed. Okay. So this lone pair is donating to whom? R actually. So what happened here? R, N, R, R, R. Now nitrogen donated lone pair to whom beta? The lone pair is given to whom actual nitrogen? To alkyl group here. So that is the reason nitrogen will get a positive character. Now this is actually what X minus, no, when X is taken as a bonding electron, X minus, minus X minus will come here and it will settle like this. This is called counter ion. Now this one is called quaternary salt. It is called quaternary salt. Now this is about the ammonolysis reaction. Here important things, if you observe what happened, what are the important things we have to learn here? Now what type of reaction it is? It is a nucleophilic substitution reaction. Correct or not? Let me see whether it is a nucleophilic substitution reaction or not. Now what happening here? If you observe, I am taking again CS3Cl. I am taking CS3Cl. I am taking reacting with ammonia. Reacting with ammonia, the lone pairs will attach on the carbon, and chlorine will be removed here. So what we are going to get here? CH3, isn't it? NH3, isn't it? Positive charge. Now this is a nucleophile substituting what actually? Chlorine. Nucleophile substituting the chlorine actually. Isn't it? Ammonia is a nucleophile substituting the chlorine. In the place of chlorine, what we got? Ammonia. After that, nitrogen, when it is having got a positive charge, is highly unstable, right? It is a highly unstable, like this, highly unstable. So what happens here? One of the hydrogen will be lost here as a minus H plus here, without this bond, Now bonding electrons are taken by whom actually? Nitrogen. Because of this, what we are going to get here? H3, NH2. This is the primary amine. In all the cases, the reaction takes place in this manner only. Now, it is which type of reaction beta? Nucleophilic substitution reaction. Maybe in MCQs, they may ask this type of question. Ammonolysis of alkyl halide. Which type of reaction? Nucleophilic substitution reaction it is. Right? Now, next, if you observe what happened, in this we are getting how many types here? Primary, you are getting, secondary, you are getting, tertiary, you are getting, finally, you are getting what? Quaternary salts you are going to get. You observe this one, primary, first mole of alkyl halide, secondary, if you take second mole of alkyl halide, tertiary, if you take third mole of alkyl halide, you are getting quaternary, if you get what happened, isn't it? Third mole of alkyl and fourth mole of alkyl. Here, first one, second one, third one. Okay, this one also. Only third mole only, not fourth mole. Only 3 moles are required here. Sorry, because already one alkyl group is there. No, so 3 moles are required actually. So this is actually what? Ammonolysis of reaction. Okay, for example, I'm writing one reaction here, isn't it? CH3, NH2. If I take what happened like this, plus, sorry, Cl I'm taking, sorry. Here actually 4 required, but actually that started with primary ammonia beta here. That is the reason we required only 3. But in the case of this one, where we started here? From alkyl halide we started here. In this case, how many required here? 4 are required actually. Understood here. So that is the reason we are getting here 3 only. Now, what I'm saying here, if I take what happened, CS3, not CS3, just a minute. Now, if I take like this is a very important one. CS3 chlorine reacting with ammonia. reacting with ammonia, excess of ammonia, what product we get here? Second thing I'm writing here, I'm writing, all of you listen, CS3Cl plus ammonia. I have taken excess of methyl chloride. Now, which will produce here as a major product? What will be the major product here and here? What is the major? Anybody? In one case, I have taken ammonia excess. In other case, I have taken methyl chloride excess.
In ammonia excess, we will get the
Primary amine. If I take methyl chloride excess,
primary, secondary, tertiary, and quaternary.
all we get. You see, observe. If you get any doubt, you can see like you see here what happened. Now, in this case, I have taken, for example, if it is methyl chloride, just imagine this is a methyl chloride here. 1 I have taken, 2 I have taken, 3 I have taken, 4 I have taken. That means 4 alkyl chlorides I have taken. 4 alkyl chlorides I have taken. Excess I have taken only 1 mole of ammonia only. When you observe this reaction, observe from here 1, 2, 3, 4. If you observe primary, secondary, tertiary, otherwise you can observe here also. We have taken only 1 mole of ammonia and I have taken 4 moles of alkyl halides here. I got all types here. So that is the reason what happened. If I take excess of methyl chloride, this I will take excess. What we get? Primary we get, secondary we get, tertiary we get, even we get quaternary salt also we get. But here I am taking only 1 mole here. Even though if you take excess of ammonia, there is no problem for us. Because only 1 alkyl halide, what we going to get here? CS3 NH2, only primary amine we get here. There is no secondary amine, there is no tertiary, there is no quaternary. Now, the question arises, how to get only primary amine? How to get primary amine, isn't it? This is the thing. Primary amine is obtained as a major product by taking large excess of ammonia. When you take excess of ammonia, what we are going to get here? Primary amine we are going to get. Understood?
Yes, sir.
Yes, sir.
So primary, secondary, tertiary, how you are getting understood? No, this is the important one. Now this one is actually when you add this RNH2, no, when you add something, what happen? This whatever this HX will be removed. No, if it add what happen, we can remove that one. NaOH, we're adding NaOH. Okay. For example, actually what happens here? No, right here. Actually, what happens if you have something what RNH2 is produced, but what is the byproduct beta in this preparation? What is the byproduct you are going to get? Anybody? In the preparation of primary amine, what is the byproduct we got here?
HCl.
HX or HCl, whatever it may be, HX or HCl. So what I am writing here, so in this case, the primary amine and also we are getting HCl, right? Or HX, whatever. Now this is the base. This one is acid. Now they can react together, no, because base and acid always react here. So this is the major product we got. This is the byproduct we got in the preparation of primary amine. So both will react to give what actually this one RNH3. There is a chance of getting like this RNH3Cl. Nitrogen get a positive. In that case, what we have to do? Add some base here. Now immediately what happened that H plus and Cl minus will be removed here. H plus will taken by OH minus and this will convert into water. And the Cl minus will taken by the sodium, convert into NaCl, and the remaining will be what here? RNH2. It is not very important for us, but I'm saying what happened when you get a byproduct like this here. When you are getting a byproduct, this one HX here, this will react with what happened? This RNH2 because it is acid, and this one is a base here. So what you are going to get here? RNH3HX you are getting. RNH3X you are going to get. So I want actually primary. This one I want actually. So in that case, what we are doing here, we are adding what here? NaOH, we are adding that. Right? This is about what? This thing. Now, if you observe this example 3.13.1, you can do all these things. See, I have taken ammonia, ethyl chloride, I got a primary amine. Next, I got a secondary amine. Next, I got a tertiary amine. Next, I got a quaternary amine. Very simple or not? You can do this one. You practice this reaction in your notebook, all of you. Now here, C6H5, I told you, no, you can't take this one. Don't take chlorobenzene. Chlorobenzene will have a double bond character here, right? Don't take the chlorine here. Why? Because when you take a chlorine, what happens here? It will have a double bond character. Where here? The lone pairs of the chlorine will be donated here. So we are going to get a double bond character here. So that is, I already told you, chlorobenzene does not undergo any nucleophilic substitution reactions in the halobenzene. I told you this. What is the reason means we discussed 3 points actually. Getting double bond character, shorter bond length, and heavy nucleus charge over benzene ring. These 3 reasons already we discussed in the chlorobenzene. Now what character we got here? Double bond character. Now cleaving this one, what happened? Very difficult. It's a strong one. So cleaving this one is very difficult. Don't take the chlorobenzene, but you can take like this. You can take this part. This is not what, can it form what double bond character beta? Is it possible? Double bond is possible in this case. If I write like this, double bond, resonance is possible? Resonance is possible?
No.
No. Why? Because lone pair should be in conjugation. See, lone pair and pi bond in conjugation. Here, lone pair, after that you are getting got sigma bond here. So no conjugation here. No conjugation, definitely it will participate. This is called what? Benzyl chloride. The name of this one is called benzyl. You can take benzyl chloride, okay, for ammonolysis. You see, you can take benzyl chloride for ammonolysis, but you can't take what? Chlorobenzene. See, that compulsory we should have sp3 carbon over here. Sp3 carbon. This will prevent what actually? A resonance. Therefore, we can take this one. Same thing. So, for example, we'll take one exercise here. I'll take some exercise here, simple exercise. Let me see. It's already we are. So here, if you observe what happened, I want this compound better. I want this compound. N and dimethyl benzylamine. I want N and dimethyl benzylamine. That means on nitrogen, what groups you are having? Methyl group is there. Methyl group. Otherwise, what happened? You take another one. C2H5. C2H5, I'm taking different one. All are different, I'm taking CH2, then C6H5. Now I have to add on nitrogen. How many groups I want to add? One benzyl group I want to add. I want to add benzyl group. I want to add methyl group. I want to add methyl group. And I want to add what? Ethyl group. All these groups I want to add on over nitrogen here. In that case, what we have to do? You start from this one. You start from this one. C6H5, isn't it? Nothing but benzene, CH2, Cl, reacting with ammonia. Take ammonia here, NH2, ammonia you take, remove HCl. Now what we are going to get here? C6H5, CH2, NH2. Right? Next, I am writing this one NH2 like this. Like this, I'm writing. Next, I have to add here what happened? Methyl or ethyl. So I'm adding something but ethyl group, something like this. Ethyl group I'm adding. In that case, what I have to take here? I want to add ethyl. What I have to take here? What group I have to take here?
CH3, CH2X or
CH2, CH3, CH3, CH2, Cl or anything you can take. Cl or bromine or iodine you can take. HCl is removed here. Now I got here what? C6H5. CH2, NH, I'm writing here. Here, this part I'm writing over here. CH2, CH3, I'm writing down. No problem. I want now methyl group. Now what I have to add here? I want methyl group over nitrogen. Which group I have to add here? Which reactant I have to add here?
CH3X.
CH3, Cl. Or you can take even bromine also. No need to take every time Cl. No, you can take even bromine also. CH3, HBr will be removed. Now we are going to get this compound. Okay, these all reactions are which type of reactions? Nucleophilic substitution reactions. I think everyone is understood.
Yes.
Yes, sir.
Right, no doubts, no? You practice this better. If you practice what happened, it will be easy for you. Very, very easy for you. Otherwise, what happened? Even small reaction also, it will be difficult if you don't practice. Practice makes perfect. Okay. Whatever it may be, even some people feel what happened, difficulty organic, but when they practice what happened, organic becomes what happened, very simple for them. Now let me see third one here. Third one is very, very simple beta. Third reaction we can easily also remember here. Third reaction is important one. Now what happens here? What we are converting? In this case, we are converting nitriles. What is the meaning of nitrile? Cyanides. Nitrile is nothing but cyanide. Now this is converting into primary amine. Now in this case, we don't get the secondary amine. Whatever you do, we get only primary amine. Why? Because in examination, they may ask this type of questions here. Following in which reactions only primary amine is produced. In that case, it will be useful. In this reaction, reduction of nitrile, reduction of cyanides will convert or will give what? Only primary amines only. We get only what? Primary. You note down in the notebook like this here. In this reaction, we get only primary amines are produced here. Produces only what happened? Primary amines here. The reagent we are using, we can use hydrogen in presence of nickel, platinum, palladium. Or we can take what happened? Lithium, aluminum hydride. You can take lithium, aluminum. Most of the case will take lithium, aluminum hydride only. This is the right. I'm making star mark by because most of the case lithium, aluminum hydride is taken in examination. Or we can take what happens? Sodium amalgam in presence of ethyl alcohol. So three reagents are there. Lithium, aluminum hydride, hydro in presence of nickel, platinum or palladium, or sodium amalgam in presence of ethyl alcohol. So these are the three reagents we are using to convert nitriles into what happened? Primary amine. Now how to remember this? How to remember? Very simple beta. Very. I'm writing one example here. CH3, isn't it? Cn. Now this one I'm doing with what? Hydrogen in presence of nickel. You can take any reagent. I'm taking here hydrogen in presence of nickel. So for our understanding, what I'm writing, this part I will write in the form of bonds like this. C triple bond N. I'm writing C triple bond N. Here also C triple bond N is only there. Now how to make the product here? When you may break a 1 pi bond, when you break 1 pi bond, I will write here just to write this. So we'll take what happened, one example here, CH3, Cn we have taken, no, CH3, C triple bond N I have taken. Now reacting with one, I have taken hydrogen presence of nickel I have taken. Now what happens here? When you break 1 pi bond, put one hydrogen here, put one hydrogen. When you make another pi bond, what happens? Put one hydrogen here, put one. Equally distribute the hydrogen. You cannot break the sigma bond because sigma bond is very strong. This bond is very, very strong. Where pi bond, you are learned in the 11th class. Pi bond is what? Weak in nature. Therefore, we can break the pi bond, but not the sigma bond. Now what we get here, beta? CH3, CH2, NH2. Very simple or not? Primary amine, ethyl amine or ethanamine we are going to get. You have tried the nomenclatures, ethanamine, ethylamine, isn't it? This is called what? CH3CN, ethane nitrile. Ethane nitrile it is, ethane nitrile, or acetonitrile also we can call. Acetonitrile is a common name, better. The common name, this one is the IUPAC name. Acetonitrile, ethane nitrile will convert like this, right? Because two carbons are there, ethane. Acetic acid, CH3C double bond OH, same like that, it is called acetonitrile. Any doubts you are having in this one? Now we'll move to what? Reduction of amides here. Reduction of amides. Amides on reduction with lithium aluminum hydride. Again we got lithium aluminum hydride, you observe. Again we got lithium aluminum hydride. Now in this case, what is happening here? Again, this part will convert into what here? CH2 group here. Here also we are going to get what? Primary amines only. Here also we are going to get only what? Only primary amines. You write in your textbook, only what? Primary amines only. We don't get the secondary amines and tertiary amines. Now what happens here also? What happens? Same thing is happening. R, C double bond O, NH2, right? Now what happens here? Now what you are doing? You are breaking the bond over, first of all. Here. You are breaking one bond. You are keeping one hydrogen. You are keeping one hydrogen. Now, even though this sigma bond we are breaking, why? Because this OH will want this water, get that hydrogen to get converted into water. So what I'm doing here, I'm breaking here also one hydrogen, and I'm putting here also one hydrogen. Same like that. Now what will convert? It will convert into what here? Water. To convert into water, to undergo dehydration reaction here, it will takes the two hydrogen. Now what we are going to get here are CH2, NH2 only. Understood better? Now the important thing is that what you have to remember, reduction of nitriles, reduction of amides, isn't it? Reduction of nitriles, reduction of what? Amides. Both will produce what? Primary amines. This is the important point we need to remember. Reduction of nitriles, reduction of, isn't it? Amides. Both are giving what? Primary amines. Here amide means what? RC double bond NH2. Here nitrile means what? RC triple bond NH2. Right? This is about the reduction reactions here. We completed now reduction reactions. Now we see a Nemour reaction here. Gabriel phthalimide synthesis reaction. Gabriel phthalimide synthesis reaction. Let me see now. Now, this reaction is what very lengthy, but what I will do here, I will make this one very simple for you by writing like this here. Here I will make you for easy understanding here how to remember this one. Gabriel phthalimide synthesis reaction. Now, first of all, you have to write phthalic acid. I think phthalic acid we already discussed here in the carboxylic acid. This is the phthalic acid. Okay, phthalic acid. This is a phthalic acid. Everyone knows, I think, phthalic acid. From this we get phthalic amide. How we get? Already it is there in the, isn't it? Carboxylic. Again, I am right here. NH3 when you take 2 moles here. Now what happens here? NH3 I am taking 2 moles here. It's already discussed in the last chapter. NH3. This is NH3. I am taking here also what happened? NH3. Now here what happened? Water is removed. And here also what happened? Water is removed. Now what we are going to get like this? C double bond O, NH2. Here also what happened? C double bond O, NH2. Now next what you do here, you take this one, you write NH2 like this here. Better to write NH2 like this here. Shall I write like this NH2? Now what happens here? In this case, ammonia will be removed. In this case, ammonia is removed. Ammonia is removing. Minus NH3 is removed. Now this part will attach over here. This bond will attach over here. Okay, now what we get here? Phthalimide we get here. C double bond O. And here also what happened? C double bond O. Here what we are going to get? NH. This is called what? Phthalimide. Okay. Now in textbook they given, you observe here what happened. This is the phthalimide actually they given. This is the phthalimide they given actually. Right. Now let me take the further reaction. How the reaction will take place with this phthalimide. Now, some important things are there. Nobody generally these questions are very important in this one. Very important questions are there in this reaction. Let me see this one. Now I will take again phthalimide to undergo chemical reaction here. All of you observe carefully here. When you observe the mechanism, it will simple for you. Again, I am writing what here? Phthalimide I am writing. Again, I am writing here phthalimide like this. This is the phthalimide, right? Now, definitely it is having a lone pair here. So, what we can call acid or base beta it is? Phthalimide is acid or base?
Base.
Right. Now, I am taking base or, no, okay, right. Now, I am taking what actually here? KOH, right? Now here it is a base, no? Lone pair you are having. But what is happening here? Nitrogen is more electronegative. It is a more electronegative. Generally, it is a more electronegative. Compare what carbon like this. In that case, what is happening? And OH minus is there. Now, what happens here? It takes the bonding electrons like this because of more nitrogen and hydrogen. Which is more electronegative better? Between nitrogen and hydrogen. Which is more electronegative?
Nitrogen.
Therefore, what happened? Nitrogen takes the bonding electron and hydrogen is released as H plus here. Therefore, what happened? Minus water will be removed here. Minus water. Now, what will be the remaining one? I am writing over here. You observe here. What will be remain here? Observe this one. C double bond O. C double bond O. What we get beta? N minus we get. Why you are getting N minus beta? Because the bonding electron, the two electrons here taken by whom? Nitrogen, and H is released as H plus. Without any electron, hydrogen is given to what? OH minus. Now this is K plus, no. Counter ion I can put here like this because of counter ion. Isn't it? Wherever negative charge is there, or we get a positive charge. This is called what? Something negative charge we got actually. Next, what I am taking? I am taking this part as a nucleophile. This part I am taking as a nucleophile. Next, I am taking something like this. CH3Cl I am taking. CH3Cl I am taking. Now, this nucleophile attacks on the carbon. Now, carbon gets the 5 bonds, no. So, the Cl will be removed here. So, this K plus and this is actually what? Cl minus is removed. That means KCl is removed here. Okay. Now, nitrogen attacking on the carbon. Now, what we get now here? You observe. C double bond O, okay, C double bond O, we are getting here nitrogen and CS. This we are getting N-methyl toluene. N-methyl toluene we got it. This is a stable one. N-methyl toluene. N-methyl toluene. Next, what we are doing here, finally, we are using hydrolysis, basic hydrolysis, OH minus in presence of water. Basic hydrolysis we are doing. Basic hydrolysis. Now, what happens here? Now, we have to break where the bond. Now, carbon is what? Positive character, nitrogen is negative character. Now, break here bond. Now, put here what? OH. I am adding water on only? No, I am adding water. Here we are getting hydrogen. We are getting OH. Again, we are getting hydrogen here. We are getting OH. Why only like this? Because carbon, oxygen is negative character. Carbon is positive character. Definitely OH minus will go to where? Carbon. H plus will go to where here like this. So what we get here? CS3NH2. Getting or not? CS3NH2, right? CS3, this part. CS3NH2. And this part will be what? Toluic acid. Now we got again toluic acid is formed. C double bond O and again C double bond O, OH, OH. Now we are getting only primary amines are possible. In this case, we don't get again secondary. Why? Because if we secondary means what? It will look one more methyl group like this. In that case, what happened? Because bulkness, what happened? It will be what? Highly steric in this. It's already it is bulk molecule, correct or not? It's already bulk molecule. Putting what? One more methyl here, what happened? Very difficult for us. So because of steric reasons, because of steric hindrance, what happened? We can prepare only what? Primary amines only. So if they ask what happened, a question like this, following which method is not unable, sorry, which method can produce primary, secondary, tertiary amines? Which method can produce primary, secondary, tertiary amines? First method, ammonolysis of alkyl halide. Second one, reduction of nitrates. Third one, reduction of amides. Fourth one, what happened? Gabriel toluene reaction. What will be the answer, beta?
Ammonolysis.
Right. Ammonolysis reaction. Now, here one important question they're asking in examination. Okay, first is what? We can prepare primary amine only. We can prepare only what happened? Primary amine. Now, one more thing what happened? You can't even prepare aniline also. You cannot prepare even, it is also primary amine. It is also primary, but it is aniline. You can't prepare even aniline also. So one exception, primary amines, aromatic amines cannot be produced. Aromatic means benzene containing compounds. Why? Because if you observe here what happened, I am taking here CH3Cl. If you want to get aniline, what I have to take? Anybody? I want to get aniline, for example. What here I have to take? Anybody? In the place of methyl fluoride, what we have to take? Anybody?
Benzyl chloride.
Chlorobenzene. Okay. Benzyl chloride means this one. This is the benzyl chloride. There is a difference is there between. Now, if you take chlorobenzene, what happens, beta? Double bond character we get here. Because of the resonance, what happened? Double bond character we get. So, If you take like this, what happened? Double bond character we get. So here also, this is not true. So in examination, they are asking like this. In Gabriel-Thalmaid synthesis reaction, which can be produced. Okay, which can be produced. If they given like this, CS3NH2. Second thing, what happened? Something what happened? Yenlin they taken. Yenlin they taken. Third one they taken, what happened? CS3N, CS3 like this. Fourth one they taken, what happened? Tell me which can be produced and which cannot be produced in the Gabriel-Thalmaid synthesis.
First one can be produced.
First one can be produced. Second one is possible?
No.
No, second
Sir.
cannot be possible. Secondary cannot be possible. It's a primary. Is it possible?
No.
Aniline we can't produce. Is it possible? It's also primary amine. Is it possible?
Yes.
It can be possible. But you may get you may get a question like, well, the benzene is there? No. But even though benzene is there, you observe here, nitrogen is bonded to sp3 carbon, in which this type of resonance is not possible. If I take something like this, what happen? If I take something like this, what I'm taking is CH2, Cl I'm taking, here I have taken. You try this one compound, same mechanism. Now there is no type of resonance here. I'm saying all primary amines are possible, except what happened, in which resonance is possible, they cannot be undergo reaction. Yeah, resonance is possible. In this case, chlorobenzene, resonance is possible, aniline is not getting it. But when you take benzyl chloride, when you take what benzyl chloride, isn't it? There is no resonance because sigma bond, there is no resonance. It's a primary amine. The primary chloride, definitely we get a primary amines here. So 1 is possible and 4 is possible. Now what you have to do after the class, what you have to do, you take some more examples here. Try mechanism here. What are mechanisms you have to follow, you see here. I want something, what happens, CS3, CH2, isn't it? NH2 I want. Now how to get this one? In Gabriel-Thalmaid reaction. Okay? Gabriel-Thalmaid reaction, how to get this one? You practice with that, whatever the mechanism is given, practice that one and write down the problem. In examination, they may ask this question. Mechanism is there in syllabus, therefore they will definitely, aldol reaction mechanism is not there, no need to practice that one. But here you have to practice because in textbook it is given. There is a chance of getting this. But major important is what? Two things are very important. First one, we can prepare only primary amines. Second thing, except what happened? Aniline. Except what? Aniline. If you remember, these 2 points will be useful for MCQ questions. Right? Next, we'll move to what? The last reaction, 6th reaction. Isn't it? After that, we are going to see the physical properties. We'll discuss day after tomorrow. Right? So 6th one, what is that? It's also Nemer reaction. Hoffman bromamide degradation. Hoffman bromamide degradation, isn't it? Degradation means removing or less we are going. For example, you observe 1 carbon you are getting what less here. You are losing 1 carbon here. That is the reason what happens, the degradation, isn't it? Now here also we get only primary. In this also we are going to get only primary. Now what is the reagent we are using here? Bromine in basic solution, isn't it? Bromine in what? Basic solutions or ethanoic solutions we can take of sodium hydroxide. Bromine presence of base. Bromine presence of base. Now you take this one. What is happening? I'm taking an example like CH3 I'm taking here. C double bond O, NH2 I'm taking here. Now what is the reagent I'm writing here? Bromine in presence of base. I can take KOH also I can take. Because base NaOH I can take KOH also I can take. Both are what? Bases. Now what happens here? We are losing what? This C double bond O group here. Now what we get directly? We get CH3NH2. Completed. There is no mechanism, no need to practice the mechanism. You got again primary. You got again primary. Now this is called what? How many carbons are there, beta? How many carbons are there here in this case?
2.
2 carbons are there. Therefore, you have to call eth Two carbons. Between carbon, single bond is there. Ane, and this group is called what? Amide group, ethanamide. It is called ethanamide. Ethanamide is converting into methanamide. That means in the degradation reaction, eth is converting into your methane. But because one carbon you are getting less number, therefore degradation reaction. Now my question is here. I want ethanamide. Right? Now I have taken which reagent? Bromine presence of I have taken NaOH. Now can you say what is the name of this reactant?
Propanamide.
Propanamide.
Definitely we have to take amides here. Definitely amides will convert into what here? NH2. Now here there are two carbons are there. So one carbon we have to take less when you write in product side. So here I have to take three carbons. CH3, CH2. This is called what? Propanamide. So propanamide will convert into ethanamide like that. In this way we get number of questions we will get in examinations as a conversions. Now 13.2 if you observe, this one is actually what? Again ammonolysis reaction, isn't it? Not ammonolysis. Sorry, it is not ammonolysis reaction. Because why it is not ammonolysis reaction? Because here you have how many carbons are there? Two carbons are there, here three carbons are. That the converting, sorry, they are not reacting, sorry. They react, what happened? They are ammonolysis reaction. These two are reacting, that is called ammonolysis reaction. But the question is that here, how to convert ethyl chloride into propanamide? In this case, what we have to do? Very simple. When you treat NaCN with chlorobenzene, this we have discussed where in the alkyl chlorides, nucleophilic substitution reactions of alkyl chlorides. If you observe what happened, there we discussed here, nucleophile is CN minus here, attacks over on what happened? CH2, SN1 reaction, SN2. Do you remember SN1, SN2? All of you? Now
Yes,
minus
sir.
NaCl is removed here. Now in the place of Cl, nucleophile Cn minus attacks here. We got propane nitrate. After that, you know, this can be done with hydrogen presence of platinum or lithium aluminum hydride. If you take what happened, you can break the two pi bonds here and put here two hydrogens and put here two hydrogens, and you are going to get the propanamide. Okay, same thing here also. Same reaction. Both are what? Same methods only. So you can do this one as a conversion. You can practice this one as a conversion here. Understood here? Conversions. Any doubts you're having? Next one, if you observe the amide which gives propanamide by Hoffman bromide reaction, which will give propanamide beta? CH3. Just now we discussed here. CH2, CH2, NH2. This is called what? Propanamide. Now, which is giving in Hoffman degradation?
Butane.
In presence of OH. So definitely it will be what? Butanamide, right? The amine produced by the Hoffman degradation of benzamide. So for example, if I take something like this, I'm taking what happened? PA, C double bond O, NH2. Now this is called what actually? Benzamide beta. Benzene amide, benzamide. You can write this one like this also. PH, C double bond O, NH2. Both are what? Same only. In the place of this group, I'm writing like this. Both are what? Same only. Both are same only. Benzamide only. It is also benzamide only. Now, when you do the this one, which method? Degradation method. Hoffman bromide degradation method. Bromine in presence of something you're adding NaOH or KOH. Or sometimes they make you like this also better. Bromine in presence of OH minus also they make you. Both are what? Same only. NaOH or OH minus. Both are what? Same. Because this reaction taking place basic medium. Now what we have to do? Remove C double bond with NH2. What we get here? The name of the product will be anybody?
Benzenamide.
Aniline or benzenamine, okay? Or aniline simply we can call this. So with this what happened? I have completed what? All preparation methods of, isn't it? This amines here. So how many we have discussed today? We have discussed how many methods beta? 6 methods we have discussed. Out of these 6 methods, only one method can produce all type of amines, and remaining all are producing what happens? 6 method: Hoffman bromide degradation, Gabriel-Thallimer reaction, reduction of amides, reduction of nitrates, isn't it? They're all producing what actually what? Only primary amine. And this one is producing what happened? Ammonolysis is producing what happened here? All types here. And this one will produce always what happened? Only primary only. It's also produce only primary. You can't get any secondary. Here also it will get primary only. It It will get only primary. This will get primary, secondary, tertiary, even we get quaternary also. And the remaining all are giving what? Primary amines only. So this way, what happen? You may get any number of n number of questions here. Okay. We'll see any exercise is there. Let me see that some exercise. Most probably we get IUPAC nomenclatures here and basic character. So most of the questions we get tomorrow only. Okay. Most of the questions we get tomorrow, but the important thing is that amines, preparations of amines will be very, very important. They comes in conversions actually. You see here, Hoffman-Bromide reaction is there here. Describe a method, identification. This will get next class here. Gabriel method, ammonolysis method, isn't it? Right? This one also we discussed now. This method, can you do this one? Is it possible for you better? Now I will take something, just 2 minutes I will complete here. CS3, CH2, I am doing this one better, iodine. And just now we done this one, I think, right? CN is a nucleophile, attacks over the carbon. NaI will be removed. In the previous case, I removed NaCl. Now I am removing NaI. Which reaction it is? Nucleophilic substitution reaction. SN2, because the primary amine, the primary alkyl halide, primary alkyl halide, SN2 reaction. What we get better? CH3, CH2, Cn. Now when you do partial hydrolysis, this is not comes here, it will next topic it will be, but anyhow doing this one, partial hydrolysis. Only one time if I do what happened hydrolysis, what we get here? CH3, CH2, C double bond O NH2. C double bond O NH2. After that what happened? I think you know this one. When you add what happened? NaOH and bromine, what happens? You know this one. This will be removed. I think you know this one. Only thing is that to explain to this one only, I am taken this reaction. Cyanates on complete hydrolysis. Remember here, CS3, this we discussed last class in the carboxylic acid. Cyanates on complete hydrolysis. Already we discussed this one. Complete hydrolysis. Cyanide will convert into what actually? CS3, CH2, COOH. COOH. If I take partial hydrolysis, partial means only 1 mole if I take what? In that case, it will convert into CS3, CH2, C double bond O NH2. This mechanism and how shortcut everything I given in the carboxylic acid. You refer carboxylic acids here, properties of the carboxylic acid. I given how to get this one mechanism I given. Shortcut also I given. You refer that. Okay. So this is a very, very important type of conversion. It is very important conversion. The remaining conversions will take day after tomorrow, right?